Good morning. Welcome to one more lecture of sustainable manufacturing, and today we are going to discuss about productivity and sustainability and the mathematical considerations associated with it, so that in the next lecture of optimization we can talk about how do we consider different factors that are relevant for optimization of maintaining the productivity while trying to achieve sustainability. I am Dr. Deepa Philip and I am from IIT Kanpur. So let's think first. We all know about the word called economic growth. So this phrase, economic growth, is one of very important phrases because this phrase contains, my ink color got changed. This phrase contains a lot of, this is like a, I would probably say it's a misused term, because lot of inherent misunderstandings are part of this. So for the purpose of this course, we need to understand when we talk about economic growth, what we are talking about. So on the contrary to the belief, economic growth is neither intrinsically good nor bad. It is not necessarily good or not necessarily bad. So the most of the time the term that we use in this class, economic growth, it is used under, it's something that promotes the fulfillment of basic needs and increases the quality of life. So you are supposed to do two things out of this. One is fulfill the basic needs. The basic needs includes housing, clothing, food, education, like this. So the economic growth allows you to fulfill of the basic needs of an individual or a human being or a society, and also it increases the quality of the life. Quality of life can include, you can think about as increased life expectancy, see, reduced mortality rate, transportation, there are a lot of things, healthcare, many aspects that comes out as a part of increases the quality of the life. So it is good that it promotes. So the good aspect of it is this, the economic growth is good because it promotes the fulfillment of basic needs and increases the quality of the life. Now at the same time, since it is promoting something, it also undermines the same. Undermines what? The same is basic needs and quality of life. These things, the same in the long term, mostly through adversarial environmental impacts. So this is the bad side of it. It will give you, yes, fulfillment of basic needs and quality of life immediately, but in the long term it undermines the quality of life and basic needs in the adversarial environmental impact. So let me give you an example, a big example. Everybody heard about green revolution. This is in India, it is increase in agricultural productivity. We all heard about Dr. M.S. Swaminathan, who was the champion of this whole thing. So what we did is we utilized fertilizers, high yielding varieties, and pesticides to increase food production. So what are the advantages of this? The main advantage of this was, poverty reduction, elimination of famine, etc. So obviously the standard of the living and the basic needs of the people, the fooding was fulfilled. But what is the bad side of it now? The bad side of it is that polluted land bodies, increased diseases like cancer, then extinction of species, of natural species, etc. So that in the long run, it also, even though it reduced the famine, it increased the food grain availability in the country, it also is now adversely impacting the life of the people through the environmental or the ecological impacts it has. So you have to think about as the economic growth or productivity. So you always have to think about this way: productivity has two sides, the positive and negative. Okay. So to address the negative sides of it is where you use sustainability. Okay. So think about it this way from for the rest of this course, so that we are using sustainability or we are incorporating sustainability into our coursework to actually minimize the effects of the adversarial effects of the in productivity or economic growth. So now there are many definitions of productivity, and we have studied quite a lot of definitions of that. So the main definition of productivity, okay, if you think about it, or how do we define this? So the productivity is the relationship between what? Between outputs generated by the system and inputs that are used to create the output. So if you take a ratio of both, then you can think about this ratio as a productivity. So you have the relationship, it's a relationship between the outputs generated by the system. So the system has some outputs that is generated, and there are inputs that are used to create that output. This gives you the productivity. So P is equal to O over I. This is the simplest way we can write this as in a mathematical form. So let's keep this to this level, so that when we get into the rest of the class, we would not have any problem with the definition of productivity. So it is the outputs that are generated by the system, the ratio of the outputs to that of the inputs that are used to create that output. We term that as productivity. So if you look into this, we have a interesting aspect. The system, what are the inputs of this? The inputs of the system includes, there are multiple inputs. Land is the land parcel in which a factory is built. So factory land, you can think about it this way. People, which is human resources. Then you have capital, which is the money. Okay. Facilities, this includes machines, forklift, crane, etc. Okay. Sorry, equipment involves. Facilities involves like painting booth, etc. I am just giving rough examples. Equipment, we already said this is what equipment is. Tools, okay, we can talk about different tools, drill bit, jakes, fixtures. Energy, this is electrical, okay, or it can be also thermal, or you use multiple energies to take care of this. Materials, iron, aluminum, plastics, etc. Information, which includes CAD drawing, okay, production plan. These are all inputs. All of these are inputs into the system. And if you look at it from a systems and overall viewpoint, this transformation is typically what we call as the manufacturing. It can be in two. The transformation process if it produces transformation, if it produces goods, then we call it as manufacturing. If it produces services, then we call it as operations. Okay. We studied this, you might have studied this in different textbooks. So, what we are talking about is the manufacturing transformation. Okay. So, you transform these inputs, all these inputs into some output. Here is some value addition happens. Okay. Value addition happened or occurred. Where did the value addition happens? So, the value gets added here. Okay. The system does the value addition, or the transformation process gets the value addition, or the manufacturing process does the value addition. So, you get into the form of goods and services. We are focusing more on goods because we are in the manufacturing side, and these goods gets then shipped to the customer. Okay. So, then the productivity we can measure it this way. It is the ratio of this to that of these inputs. Okay. So, that is the system's approach or the system's view of the productivity in this regard. Okay. So, what we will do is we will talk about how can we increase productivity. Okay. How productivity can be increased. So, the first thing that we need to think about productivity increase is it's a result of the productivity improvement, typically the PI, we abbreviate this as PI. It is the result of managing and intervening the transformation process. So, if you remember the diagram, here is the transformation process. You had inputs, you had outputs, and these outputs were going to the customer. Okay. So, this transformation process, when you are intervening means you are interfering and managing. You are basically trying to manage the transformation process. That is where you talk about productivity improvement happens. Okay. So, there are multiple ways productivity improvement will occur if this is the output increase, this is the increase sign, it goes up, input decrease. So, then your productivity will go up because P is equal to O over I. So, if this increases and this decreases, your productivity will improve. So, another example is if your output was 10 and your input was 12, and if you change this to output is 11 and input is 10, then you can see that the productivity has increased in this case. Okay. So, this is 10 over 12, this is a fraction which this is less than 1, and 11 over 10, this is a fraction that is greater than 1. Okay. So, you can see that your productivity has improved. Okay. So, anyway, just a numerical example. Other option is input remains same. You keep the input the same, okay, do not change the input, but output is increased. Okay. You increase the output. If this happens, then also the productivity will increase. So, another example of this would be your initial was 10 over 12, okay, and you can translate that to 11 over 12, then obviously you can see that the input remained the same, whereas the output has increased. So, then also the productivity will improve. Okay. Other option is output increase significantly. So, it is a large increase in output, input increase slightly. Okay. So, the rate of change here, the rate of increase, you increase output at a much faster rate compared to input. If that is the case, then also your productivity will improve. So, an example of this will be, let us say your productivity was 10 over 12, 10 was the output, 12 was the input, then you made it to 14 and the 12 became like let us say 13, then also your productivity. So, here also your input has improved, but your output has improved at a much faster rate. So, here also you will get a larger productivity improvement. Okay. Then another option is keep output the same or output remain the same, okay, no change in output. Input decrease or reduce. Okay. This strategy is typically called as the reduce strategy. You reduce the input. So, here what happens is your productivity, let us say if you assume that it was 10 over 12 and your output, it will translate, it remains the same 10, but you reduce 12 to 11 or 12 to 10 or something like that, then your productivity will increase. So, here the output remains the same whereas the input has decreased. So, that is this strategy. Another option is decrease output or reduce output slightly. Okay. You reduce output slightly, input decrease significantly. At a much faster rate the input reduces. So, here an example of would be, it will be 10 over 12 is the productivity. You make it transform to 9 and this 12 maybe get reduced to 8 or something like that. So, yes, this is reduced, but this is reduced at a much faster rate. So, this is like a the frugal strategy, people sometimes call it as the frugal strategy. So, there are multiple ways you can deal with the productivity and you can actually look at how to reduce the productivity in multiple fashions. So, there are in sustainability, one aspect that we look into is we sometimes look into, most of the time people think about sustainability as this aspect, but this is also sustainability, producing more for the same level of input, and this is also sustainability in that regard. Okay. And obviously, yes, if you can do this, nothing like this, but this is very difficult. Okay. It is not very easy to achieve obtain increased output by reducing input, not very easy, right. Okay. So, how do we measure productivity? Okay. That is another aspect we need to do. There are two measures of productivity. One is called the static and the other is called as the dynamic. Okay. The static productivity, so this is the productivity measure for a given time t. Okay. And so, this is P equal to O over I, but this time there is no, is for a given time, okay, used typically for benchmarking. So, in a simple way you can think about it is this is kind of an overall measure. Okay. Productivity taken over a large period of time. Okay. That is what the static productivity is all about. So, it is typically used for benchmarking processes. The other hand, the dynamic productivity, okay, it is measured to reflect changes in productivity between time periods. So, if you think about a 12-month time period, think about it this way, this month is 1, 2, 3, 4, 5, 6, 7, 8, 9, something like this, and your productivity is on the y axis. Okay. So, here is months, here is productivity, okay, and you have for the month of 1 the productivity is this, 2 is this, 3 is this. So, you have P of 1 will be O of output of 1 over input of 1, P of 2 productivity of the second month will be output of 2 over input of 2 the second month. So, something like this, and so system where you have productivity you measure this way, and you sometimes draw graphs and those kind of things out of this. So, this is sometimes called as a dynamic productivity. So, you are measuring the productivity over a time period, or it's not over, it's between time periods. So you are more interested in the fluctuations or changes in productivity. Okay. In this case, the static one, the productivity is more like this, you're having one average number. Okay. Whereas here you are measuring it in a different way. I hope that you guys understand the concept of how do you measure productivity. So we measure it static and as well as in dynamic fashion. Static is for a given time period, it's for benchmarking. Dynamic is between the time periods and it is used for measuring the fluctuations and changes in the productivity. So this dynamic productivity is more useful for sustainability studies. Okay. We will see how, because when we go to the optimization, then we will find that out. Right. So also there is other way to measure productivity, which is called as the we call it as the partial factor productivity, multi-factor productivity, and total factor productivity. So let's talk about what is a partial factor productivity. So the partial factor is it uses or utilizes a single input factor. Okay. So here what you are measuring here is some examples of this is okay, output per labor hours, or we can say that sales per employee. Okay. Or you can think about it as cost per employee, something like this. You can measure multiple ways, but here you are using a single input factor. Labor hours is one input factor, employee is one input factor, or you can think about it as or kilometers per hour. So that is one another input factor. So you are doing a single measure input factor here. Okay, this is very easy. The advantage of partial factor is they are easy to measure and understand. The disadvantage of this is this hides a lot of aspects of productivity. Now when we talk about the multi-factor productivity, here what happens is we utilizes more than one input factor. Why do we utilize more than one input factor? Because these are not very easy to measure and understand. Okay. So some of the examples of these would be like output per direct cost. Okay. So the direct cost includes what? So what is now the question is what is direct cost? So you are like, okay, what are the things that are part of direct cost? So then you will have input materials plus labor hours plus you can think about as overheads. Then you will say what overheads? So you will say is it the direct overhead or the indirect overhead? What is involved in this? So the problem with the multi-factor productivity is that you need to really know what are the underlying factors that is used in this input factor, that is which is more than one. So this is usually what we call as a confounded factor. Okay. So in this we have to find out what percentage of it is input material, what percentage of its labor hours, what percentage of it is overheads, or what is the contribution of these factors put together to this confounded factor. So that's why it is sometimes not very conducive to do that. Okay. But still better management is possible if you have a multi-factor productivity. Okay. That is known. Then the last is the total factor productivity, where it utilizes all input factors. Okay. So, here this is extremely hard to measure and understand. The quantification is quite tough in this case. Okay. But this helps in doing trade-off studies. Trade-off studies is important because this is where you can study which factor can be reduced to without reducing productivity. This is one question that we always ask. If we can answer this, then you are on the road to sustainability. Okay. So, from the manufacturing standpoint, we are more interested in the sustainability aspect. We are looking more towards the total factor productivity. If not, if this is not possible, obviously then we might look into a multi-factor productivity, but definitely not partial factor or definitely not a single factor productivity. So, these are the two aspects that we look into the class to optimize multiple factors in order to reach sustainability. That is what the aim in the following lectures to demonstrate to you how that is being done. Okay. So, then we talk about the measurement problem, which is a very interesting problem in this regard, because there is when you have multiple products and services. So, you have, like, think about it, for example, if you take Maruti Suzuki as an example, okay, they make many cars. They make they no longer make Maruti 800, but they have Alto, they have Swift, they have Brezza, they have, I think, Ciaz, quite a lot of models. Let us put one more model. What is another model of Maruti? Let us put Maruti 800 also, just for the time being, assume it that way. So, these products, when you have multiple products, then they will have different requirements or different inputs. Okay. So, when you have multiple products and you want to do the productivity measure, because remember, productivity is output over input. When you have these ones, then measuring the productivity, that because of the aggregation of the output, it becomes a problem, because you would say that I produced 200 Maruti 800s, 10 Alto, 80 Swift, 90 Brezza and 300 Ciaz, and then the input, these are the outputs divided by some big value of input. But then what percentage of that input has gone to this, what has gone to this, what has gone to this, what has gone to this, that clarification is not there. So, hence the importance with the case is that when you have multiple products and you aggregate all these multiple products, then that creates a measurement problem. That is what we call as the aggregation of the output problem. Then the second problem that we typically face is the varied categories, types and levels of input problem, which were the aggregation of input. So, when multiple input types are aggregated, when that happens, that also creates a problem which we typically call as the aggregation of the input problem, the aggregated I problem. Okay. Then the changes in price and cost. The main assumption in almost all the study is that the demand and price / cost, they never remain same. They are always fluctuating. So, if you draw it in a graph, it will be all over the place like this. So, you will be like, what? So, but you have to use some value to basically pick it up and study. So, you will pick up some value here and then use it to do the study, and when you are done with the study, when you come back and you find the value is not here, it is now here. So, your entire optimization has gone for a different thing. So, this fluctuations in the prices and the cost changes of both outputs, okay, it can increase, it can decrease, those kind of things, it can also increase or decrease, it does not matter. But if the cost of the price or cost of the outputs increases and the input decreases, then you are obviously in good. Like if you look at the price of the oil in this country, this is an example of that. Okay. So the price changes also creates an issue to your measurement problem. Then we come across something called as the redesign products and services. So when you change the strategy of production or process of production, then you will get into a much different input and output. An example of this is the body in white process. So if you understand automotive manufacturing, one of the things is the shell of the automotive. Earlier it used to be made and then the primer used to be painted onto that, spray painted onto that. Now what they have is, so you have the shell of the car, think about it this way, no tires, nothing, okay, no door, it's just the shell of the car. You take this car and then you spray paint, okay, so you had a sprayer here and then you spray paint everything, and that is how the primer was. Now what happens is you have a big bathtub in which the primer is kind of floating and the car gets dipped in this. Okay. So this process, this is called the body in white. Okay. So when the process got changed, then what happens is the entire energy and everything used for keep on spray painting and everything got changed because you are just dipping it in a paint bath and taking it out. And this allowed for better coating and etc. Okay. So when you redesign the product or process, so then your sustainability has now taken a different time stuff. Then comes this last one which we call as the hard to measure factors like quality. Okay. Sometimes you are saying that they say quality, you say that this restaurant this sorry, we will say that particular food is of good quality. That might be of good quality to the person who said it, the food is of a good quality. It need not be of good quality to somebody else. So because quality, the issue with the quality is that it is subjective, it is individual dependent or it's customer dependent. So it's quite hard to measure in that regard. So when you have hard to measure factors also part of this, because you still have to build a quality product. That is the main aim. Okay, build a right product for the customer. This right product is what we call as the quality product. But how do you measure this? This is tough to measure. Okay. So these are the measurement problems that are associated with the productivity side. Right. So now let's see what are the levels at which productivity can be applied to. So productivity can be applied to different levels. Okay. It can be applied to at an individual level. It can be applied at an individual level means, okay, we can talk about as a individual labor, okay, individual machine. So here we are talking more about Tom or Mary or something like this. Here we are talking about the lathe or the drill or something like that. So we are looking at the individual level. You can measure the productivity, how many parts the Tom produced. So you can say output by Tom. Okay. So that is the productivity at individual level, or output by Siemens drill. So this is an individual level productivity. So if you think about a factory as such, if you assume this as a factory and you assume that these are like drilling machines and this is the drilling department, and then you have lathe machines. Okay, this is, let's say, call it as the planing department or machining department, whatever you want to call it. Okay, and then there is some milling machines. Okay, and so you can think about the productivity of this. This is the individual. This is the group. Okay, this is the group level, because you can think about this group. Okay, or not completely. Let's say there is. Let's think about this as the group. This is better way to demonstrate a group. So this is the group level productivity. Same way we want to do the productivity of the milling department, then this is the department level. Okay, And if you want to think about this entire factory, okay, let's call this as the factory. Then this is the corporate or the organization level. This is also called as the organizational level. And you measure for all the such factories, okay, sum of all factories. If you do that, then that comes at the national level. And you do sum of all nations, then that comes at the global level. So that's how you measure productivity in a hierarchical level. In our study, we are basically only looking at up to this level, which is the corporate level. We try to see sustainability to an organization level. So we start from the individual level, we move to group, from group to department, department to corporate, and we kind of stop there as part of this course. We don't take it any further. The reason is because if all the corporates become sustainable, then obviously then it's a summation of the sustainability across the national and the global level. So this is where we call this as a cutoff point for us in this course. Okay. So the obvious question is, why is national productivity improvement important for us? That is a important question for us. And why is the national productivity is important? So everybody asks this question, and the problem with the national level productivity, why is it important, is it first, it increases the competitiveness of the country in manufacturing. Okay, let's just think about it that way. Okay, so one is its competitiveness in the country, then skill set, okay, GDP, it increases those kind of things. Then also foreign trade, technical know-how, high standard of living. Okay, then those kind of things. So it has a lot of advantages in that way, but at the same time, this we have waste increases, then non-biodegradability, that increases, pollution, okay, that also increases, then long-term diseases, okay, that increases. I'll request you guys to read something called as Minamata disease. It is a phenomena that happened in Japan. Then I'll ask you to study about asbestos and silicosis, okay, then DDT and cancer. So these kind of stuff. So these are aspects that came out of long-term disadvantages of doing the national productivity. So what in this course we are trying to do is, yes, there are benefits and demerits to this, but let us find a proper trade-off. That allows for sustainable development. Okay, so we are not really harming the national ecology and other kind of things by trying to shoot for productivity, right? So when we think about this, when we are competing at the national level on productivity, okay, it definitely leads to a high standard of living. It holds the inflation in check. That means the price of the items increase. Okay, so this is, it doesn't go up through the roof. It enhances the international competitiveness. So the country becomes, like an example of this is USA, European Union, Japan, and all, how they became quite competitive in the international. Okay, and the GDP growth is quite a lot, can give to the growth in productivity and growth in inflation. So the GDP, which is the gross domestic product, okay, the GDP growth it is partially to the productivity, and the growth in inflation impacts this. But what happens is, just focusing on GDP, focusing on single factor alone, is not going to give you a complete picture. We have already seen that. Okay. So, it is important for us to understand that we have to think about other aspects of just focusing rather than just focusing on GDP. Okay. And what are the typical measures that impacts the measurement of productivity? There are few factors that impacts the measurement of productivity. Number one is the efficiency, other one is called as effectiveness, quality of work life, and innovation. So, efficiency is typically to an extent we are trying to measure to what degree the system utilized the right things. Okay. For this sustainability course, rather than the conventional definition of efficiency, we will actually see to what extent the system utilized the right things, our transformation process. Remember, our system is like this. Okay. The inputs, then you have a transformation process, then you have outputs. Okay. So, here you are measuring. At this point we said output over inputs will give you the productivity, but we are trying to check here to what extent of the output we utilize the right things. That is what we will be trying to measure the efficiency. Whereas in the case of the effectiveness, okay, what we are trying to say is that is the product or output the right one. Are we making the right product? Okay. So, efficiency to a large extent is doing things right for us, and this is doing the right thing. So, there is a slight difference to this, but that is the way we will look into the definitions of efficiency and effectiveness in this class. Okay. Then quality is obvious. So, let us go through these terms one by one. So, efficiency is the measures the resources expected to be consumed to the resource actually consumed, or as I mentioned earlier, it is to what degree did the system utilize the right things. So, that it focuses on the input side of the system. So, for us when we say productivity is equal to output over input, we measure the efficiency. When we talk about efficiency in this course, we are focusing on the input side of the system. So, efficiency in sustainability is focused on the input side of the system. Remember this. So, what are the resources actually consumed? What was the actual consumption? This actual consumption, okay, it includes how many gallons of coolant when you are measuring, how many watts of electricity. Okay. So, that kind of thing, how many kilograms of iron. Okay. So, these are the aspects that we look at the input side. So, this measure, so to a large extent you will see in this course that we do a lot of efficiency measures to obtain sustainability. Okay. And similarly, the second aspect of this, which what we call as the effectiveness, that is a second aspect, which again my ink color changed, I apologize for this. So, the effectiveness of the system, it measures what the system sets out to accomplish, okay, and what it was actually accomplished. So, the what did you actually reach what you plan to do. So, the effectiveness is a measure of the output. So, when you have productivity is equal to output over input, the focus on the output is what you call as an effectiveness. Is the output right? As I said earlier, is it the right quality, right quantity, on time, etc. So, are you making the right product? Okay. This is an important aspect because to a large extent the lean production, lean manufacturing, everything kind of focuses on this aspect as well, making the product right and making the right product. Okay. So, here you just cannot just focus on the input as well. Well, obviously, if you focus on the input, remember, you can drive productivity by maintaining the output the same and reducing the input. We had mentioned this earlier. Okay. So, one option is this, you can focus on reducing the input, but also by focusing on the output, you might end up making a better product. Like for example, paper. Let us talk about paper as an example. Earlier paper, the major input was the bamboos and those kind of trees. Okay. And you used to get output as the normal paper. So, now instead of this, we started adding old paper also into this, what we call as the concept of recycle. Okay. So, then the input we ended up changing here, but the output still remained the paper. Now, one other way of thinking about is, do we really need the paper? Can we convert this into a digital format? Okay. This is where you are talking about being effective in a different fashion altogether. Usually, effectiveness will result in something that is unique or something that is different compared to what is already being done. So, we will take a break at this point, and we will come back and continue with the rest of the concepts later down the road. Thank you.